Welcome back to BESS Basics. I'm Mike Watson, Head of Product at Trina Storage North America. As global energy storage accelerates at an unprecedented pace, product performance and safety are drawing more attention than ever. By 2028, worldwide electrochemical storage installations are expected to exceed 1,000 gigawatt hours. And as systems grow larger, the challenges and responsibilities of ensuring safety grow with them. In our last episode, we explored how Trina Storage builds a holistic safety architecture from cell to system. Today, we take it a step further. For the first time, we're giving you an inside look at one of the most demanding validation programs, the large-scale fire test. What is large-scale fire testing? Last year, Trina Storage completed a container-level fire test, successfully validating the effectiveness of our fire protection design for the DC cabinets. This year, we're expanding the scope and performing a multi-container fire propagation test designed to answer a critical industry question. If a worst-case fire occurs in one of the containers, will the fire spread to adjacent assets? This test follows the most recent NFPA 855 and UL 9540A requirements and was jointly witnessed by TÜV Rheinland and US-based engineering firm Hiller Fire, ensuring full third-party validation. Data from this test provides AHJ's manufacturers and fire engineers with a reliable basis for evaluating compliance in installation spacings. To reflect real-world situation, we've installed 4 Elementa 2 Pro systems and arranged them exactly how they would be during commercial operation. However, the spacing between battery containers in the test has been intentionally reduced, making the test setup more stringent than in real deployments. All units were charged to 100% state of charge, and all active fire suppression systems were fully disabled. This setup allows us to evaluate pure structural fire resistance and passive protection performance under worst-case conditions. The experiment was carried out under prolonged extreme burning conditions, simulating a complete uncontrolled fire scenario. We artificially induced thermal runaway to intentionally create a fire inside a target cabinet. Once flames formed, we observed how the physical cabinet structure managed the internal pressure, how heat was released, and how the overall combustion behaved. The fire was allowed to burn without any intervention, and we closely monitored how the flames evolved and whether heat or fire spread toward adjacent cabinets. Throughout the process, the test environment replicated real installation conditions, allowing us to accurately evaluate fire propagation risks. The results are very encouraging. After many hours of continuous burning inside the test cabinet, the fire didn't spread to any of the adjacent units. All structures remained intact, temperatures stayed within safe limits, and no signs of thermal propagation were observed. In short, the Elementa 2 Pro effectively prevented propagation even under extreme suppression-disabled scenario, demonstrating strong passive protection performance and giving us solid confidence in the system's design. This large-scale fire test is more than a certification exercise. It shows us how we at Trina Storage design our products to withstand real, uncontrolled fire scenarios and prevent propagation at the system level. As energy storage deployments continue to grow worldwide, rigorous testing like this is essential to ensure that large-scale projects remain safe, reliable, and ready for long-term operation. Thank you for watching this episode of BESS Basics. If you'd like to learn more about our fire tests, safety engineering, and latest developments in energy storage, make sure to stay tuned and follow us for future updates.